Alright, in this video, we'll take a look at another example of how we can apply the sine rule to solve um, questions involving triangles where you have to find unknown lengths and unknown angles. We are still on the same case. It will be the case where two sides and a non-included angle is given. As mentioned in the previous video, we will have learned that there is a possibility of two pairs of answer, okay, or two sets of answers because of the fact that you have the sine obtuse ratio itself. Now, in this example, we'll take a look at the same exact example, rather similar example, except that this time around we will have to do some sort of rejection, and you will see why we have to reject later on. Okay, so let's take a look at the question. Try 13. Okay, those of you textbook, you can refer to your textbook itself. Okay, so in triangle PQR, QR equals to 12 cm, PR equals to 10 cm, QPR equals to 38 degrees. So again, let's just draw a random triangle. Doesn't have to be accurate. Again, we are only interested in the positions of the legs and the angles. So PQR. So PR equals to 10 cm. Sorry, PR equals to 10 cm. QR equals to 12 cm. So QR is here, 12 cm. Angle QPR is 38 degrees. And you realize that over here, the angle is still not included. Okay, included angle is just PRQ. Okay, and same thing, let's just look. Okay, PR corresponds with this angle over here. Okay, QR corresponds with this angle over here, the opposite angle. Okay, and the last one, of course, is PQ, which corresponds with this angle over here. Okay, so um, again, you want to find the all three angles and unknowns. So the one that is given, of course, is the one in blue color, which is these two things over here. Is already given. So this will probably be the right side of the equation. And the only length that is given is the only other length that is given is PR, which is 10 cm. So the angle that corresponds with it is PQR. Okay, so we'll quickly write down. Okay, sine angle PQR over the length that corresponds with it, which is PR, is equals to, okay, the two sets of length angle that is given, which is sine QPR over over QR. Then we'll sub in all the numbers. So we have sine angle PQR equals to P over PR. So PR is 10 cm equals to sine QPR, which is 38 degrees. So sine 38 degrees over QR, which is 12 cm. Multiply by 10 throughout, we have sine angle PQR equals to sine 38 degrees over 12 multiplied by 10, and then we will evaluate this and leave it in pi significant figures just so that it's easier to understand our working itself. Okay, so we will have sine 38 over 12 multiplied by 10. So we have 0.51305. Okay, so angle PQR, and because of the sine of obtuse angles is equals to sine of the acute angle, so we have angle PQR equals sine inverse 0.51305 or 180 degrees minus sine inverse 0.51305. And you realize that this is actually the same exact set of workings as steps that we did in triad 12. Actually the same. Sine ratio, substituting numbers, find the phi as F figure, then do the solve for the angle itself and two cases itself. So it's actually the same thing over here. So if I take sine inverse of the angle that we have equals to angle PQR equals to 30.867 rounding off to 1 dp, 30.9 degrees. Over here you will have equals to 149.133, which is 149.1 degrees. All right, now over here you realize that you will probably have to reject this. It might not be obvious here why you must reject this. Okay, so just to make it more obvious, Okay, the next step we will do is, of course, we'll find the remaining angle, which is PRQ. So we know that PRQ is equals to 180 degrees minus your 30.867 minus 38 degrees, and I will get myself 187 111.133 degrees, and rounding off to 1 dp, 111.1 degrees. Okay, or if you take over here, you take 180 degrees minus 149.133 minus 38, you realize that you will get a negative number. So over here, you will have to reject your answer. And the reason is simply because, okay, the reason for this is simply because if I take 149.1 degrees and I add that to 38 degrees, I will get myself 187.1 degrees, which exceed the sum of angles in triangle, which is 180 degrees. And this is why you reject. So I hope you understand why I must reject this working over here. Okay. So now that I've solved for PRQ, and there can only be one answer, there can only be one angle here, so this will be 111.1 degrees. So now I can easily find PQ itself. So to find PQ, so PQ corresponds with the angle opposite it, so sine angle PRQ equals to, then the known length as given to you, RQ or QR over sine QPR. Okay, so PQ is what I want to find, PRQ is what I found in the previous step. So sine 111.133 equals to PQ is 2, RQ is 12, and QPR is 38. So PQ multiplying by sine 111.133 degrees throughout. Okay, so PQ is simply equals to 18.180. All right, so that's it. Okay, so same exact working as try 12, except that this time around I have a rejection over here. So this is the only difference. All right. Now, in the last video of sine rule, we'll be looking at the last example. Rather, we will take a look at application of trigonometry itself in the real world situation. Okay.